All right, now let's talk about properties of real numbers. So in properties of real numbers, we have a few, and these some books have more than others. But anyway, we'll go through the properties in our book. So we have addition and multiplication properties. So each of these, except for distributive, applies to both. So commutative property, the commutative property says that it doesn't matter what order you add or multiply. So you can add a plus b, and that's the same as b plus a, right? Same thing by multiplying. A times b is the same as b times a. And you can think of that with real numbers, right? Like 3 plus 2 is the same as 2 plus 3. They're both 5, right? Same with multiplication. 3 times 2 is the same as 2 times 3. You get 6 either way. Associative property says that if you have 3 or more things that you're adding or multiplying, then it doesn't matter which 2 you add first or which 2 you multiply first. So in other words, if I'm adding a, b, and c, I can add a plus b first and then add c, and I would get the same thing as if I added b plus c first and then get a, right? Same thing with multiplication. A times b first and then multiplied by c is the same thing as b times c multiplied together first and then getting a. Okay. All right. So those are the associative properties of addition and multiplication, respectively. The identities are what you can add or multiply to a number to keep it the same. So the additive identity is 0, because if you add 0 to anything, it stays the same, right? Anything plus 0 is itself. The multiplicative identity is 1, because if you multiply something by 1, it stays the same. And so anything multiplied by 1 is itself, right? Okay, so inverses are what you add or multiply to a number to get back to the identity. So in the case of the additive inverse, what can you add to a number to get it back to 0? It would be the opposite of that number, right? The negative of that number. So the additive inverse is the opposite or the negative of a number. So the additive inverse of 5 would be negative 5. The additive inverse of negative 2 would be positive 2, right? The additive inverse of 1/2 would be negative 1/2. Okay. All right. In multiplication, what can you multiply by a number to get back to the identity? Remember, the identity is 1. So that would be the reciprocal. Okay. So the multiplicative inverse is a reciprocal. Okay. Let me write that in here. So for the additive inverse, it's the opposite. And for the multiplicative inverse, it's the reciprocal. Okay. So a times 1 over a equals 1, right? Because remember, if we have a over 1 times 1 over a, top times top, multiplied by bottom times bottom, or over bottom times bottom, we would get a over a, which equals 1. Okay. So an example of a reciprocal, the reciprocal of 5 would be, or the multiplicative inverse of 5 would be the reciprocal, which is 1/5. The multiplicative inverse of 2/3 would be 3 over 2, right? The multiplicative inverse of negative 4/5 would be negative 5/4. Okay, so there's no sign change with the multiplicative inverse. You just flip it over. Okay, whereas the additive inverse is the opposite. Now the closure property, that's one that we're going to see here, but we won't really see it in the examples. Okay, but it basically says if you add 2 real numbers, you get a real number. So a plus b is a real number. If you multiply 2 real numbers, you get a real number. Okay, and that'll become a little more important, I think, when we get into complex numbers, because then we'll have a little more dynamics there with multiplying an imaginary number times a real number and seeing what happens. Okay. All right. Then the distributive property, and this is one I'm sure you've seen before as well, but this says if I'm multiplying a number by a sum or a difference, then I can distribute the number on the outside, meaning I can multiply it to the numbers on the inside and then add. Okay. So I can multiply first here and then I can add. And this is something that's useful when you have numbers inside that are not like terms. And so that's when the distributive property comes in handy for the most part.